This project is led by IRHARF out of Indian Head, and the other AgriArm sites are participating in the study. The wheat project is sponsored by Sask Wheat, and the canola project is supported by Sask Canola. Both trials are evaluating the efficacy of spraying Envita and Nutricia. These products are biologicals and are purported to enter the plant and fix nitrogen. Now, the companies are not suggesting that the use of these products can eliminate the need for applying nitrogen fertility. It's not the same as applying an inoculant to a legume, for example. Instead, the products are purported to help supply that little bit of extra nitrogen to help finish the plant during an extended grain filling period when nitrogen may be in short supply. Syngenta Canada is the supplier for Envita, and Nutricia is being supplied by Corteva. In this study, both products were applied as a foliar application at the 4 to 6 leaf stage for both crops. The companies recommend that the products are applied between 10 to 30 degrees Celsius, preferably early in the morning when the stomata are open and plants are actively growing. These products have been used in the States on corn, but there isn't a lot of third-party data for these products on wheat and canola in Saskatchewan. Now, let's go see what we observed in our study. Here are the 8 AgriArm locations that participated in the study that was supported by Sustainable Cap, Sask Wheat, and Sask Canola. Our locations include Redvers, Indian Head, Yorkton, Melfort, Prince Albert, Scott, Outlook, under irrigation, and Swift Current. The wheat trial was set up as a factorial combination of 3 levels of N fertility and 3 foliar treatments. The low level of 50 kilograms of N per hectare was not possible at 4 of the locations due to high levels of residual soil N. So at Melfort, Prince Albert, Swift Current, and Yorkton, the lowest rates of N were actually 59, 76, 56, and 62 kilograms per hectare, respectively. Envita, Nutricia, along with an untreated control, were the foliar treatments. These were applied at the 4 to 6 leaf stage in at least 10 US gallons of non-chlorinated water. Treatments were very similar for the canola trials. However, each target rate of N fertility was 10 kilograms of nitrogen per hectare higher than those for the wheat trials. The lowest rate of N was exceeded at 3 of the locations, at Melfort, Prince Albert, and Yorkton. The low N level was actually 71, 97, and 68 kilograms of N per hectare, respectively. Sorry the charts are looking a little drab, but I just pulled them directly out of a black and white report from Chris Hilzapel. Here we're looking at the canola sites where yield was responsive to increasing N. Prince Albert and Scott are not depicted here as these sites were unresponsive to added N. Swift Current also had to be eliminated due to severe hail damage. So these are the canola sites that we're going to focus on to determine if Nutricia or Envita are providing any benefits. Here are the wheat sites that were responsive to added N. Prince Albert, Swift Current, and Yorkton were excluded from the combined analysis due to no N response whatsoever at Prince Albert, severe hail damage at Swift Current, and unusually high variability at Yorkton. Our discussion will focus on these wheat sites. Turning back to canola, here are the main effects of product on canola yield. Product A is Envita and product B is Nutricia. UTC stands for untreated control. Neither product produced a canola yield that was significantly different from the untreated control. However, at Outlook, Envita, product A, did produce a canola yield that was higher than Nutricia, product B. However, I'd file this difference under random variation. While there was no nitrogen by product interaction, we're still going to look at the effect of nitrogen fertility by product when averaged over site. Just to confirm, as seen here, that neither product significantly affected yield, regardless of the background level of N fertility. Okay, but what about seed protein of the canola? I know producers don't usually care about the protein content of their canola, but this is another way to detect any N benefits coming from either product. Unfortunately, protein measurements were missed at Outlook, but values from the remaining sites revealed that seed protein did increase significantly with increasing N fertility. However, seed protein was unaffected by applying either Envita or Nutricia. Again, there was no N fertility by product interaction, which can be seen here, as product did not affect canola's seed protein, regardless of the background level of N fertility. Switching back to wheat, we saw a very similar situation unfold. Neither Envita or Utrisha affected wheat yield relative to the untreated control at any of these N-responsive sites. No seed yield differences between products were detected, regardless of the background level of N fertility. While increasing N fertility significantly increased wheat seed protein, neither Envita or Utrisha increased wheat seed protein at any responsive site. And again, this was true regardless of the background level of N fertility. Conclusions. For the majority of canola and wheat trials in this study, significant increases in yield and seed protein were detected as N fertility was increased. However, regardless of the background N fertility, neither Utrisha or Envita further increased yield or seed protein for either canola or wheat at sites that were responsive to added nitrogen. Environment may affect the efficacy of these products. Producers who wish to experiment with these products should leave multiple check strips in order to properly assess their performance.